Hydrogen's rocket fuel is very explosive. It releases a lot of energy when it's burned. Thus, the amount of hydrogen to be used must be just right. Too much hydrogen can cause disaster explosions. So, how a chemist determines how much hydrogen to use? To answer these questions, let's learn Chapter 10, Chemical Calculations. Before we continue to discuss chemical calculations, let's recall calculation involving the mole and molar mass and calculation involving the mole and molar volume. Remember the simple triangles that shows calculation involving the mole and molar mass consists of M, and Mr. N is number of moles, the unit is mole. M is mass, the unit is gram. And Mr is a molar mass, the unit is gram over mole. And then the simple triangles that show calculation involving the mole and molar volume consist of N, V, and Vm. N is number of mole, the unit is mole. V is volume of gas, the unit is decimeter cubes. And Vm is molar volume. As the value 24 decimeter cubes or 24,000 centimeter cubes. And we have to recall about the molar mass. Yeah, we can calculate the molar mass from atomic relative mass or ER. For example, please calculate the molar mass of MnO2 if the AR of Mn 55 and O is 16. Let's recalculate. Mr MnO2 equals how many Mn atoms? There are only one Mn atom, so ArMn plus, because we have oxygen atom 2 times Ar oxygens. So the Mr MnO2 ArMn 55 plus 2 times 16. 55 plus 32. So the MnO2 87. This is the calculations, yeah, how to calculate Mr from AR, atomic relative mass. And then today we'll discuss the subtopic 10.1 calculation from chemical reactions. The learning outcomes. At the end of the lesson, you should be able to calculate the mass of reactants and products by using the mole ratio in a chemical equations. Yeah, calculation from chemical equations. Balancing equations. This is the chemical reactions, yeah, between sodium and chlorine gas. The product is sodium chloride. Sodium chloride. We can eat from these reactions. This only consists of 2 chlorine atoms, and then at the product consists of 1 sodium and 1 chlorine. Yeah, if we compare the total of atoms within reactant and products, sodiums 1 and 1, it balanced. But how about chlorine? There are 2 chlorine, but 1 chlorine and at the product. It means these reactions unbalanced. How to make this reaction balance? This is unbalanced. 2 chlorine and 1 chlorine. We can put 2 coefficients in front of the molecule of sodium chloride 2. So it means we have 2 sodium. So we have to put also 2 in front of sodium atom. So the balance equation will be 2Na plus Cl2 equals 2Na, 2Na balance, 2 chlorine and also 2 chlorine atom. These balance reactions. And then this equation can be read as 2 mole of sodium. We can see moles from the coefficients. 2 mole of sodium and 1 mole. Coefficient 1 is actually the coefficient is 1. It means 1 mole of chlorine gas. And then 2 mole of sodium chloride. Yeah, or in the term of mass, it will be 46 grams. Why 46? Because there are 2 sodium atoms. For 1 sodium atoms equals with 33 grams for 1 sodium atoms. Then how about chlorine? There are 2 chlorine atoms. For 1 chlorine atoms consists of 35.5 times 2 equals also times 2, 46. And then the products is same. When 46 plus 71, it will equals to 117 gram of sodium. It will be equals. We can calculate it. 2Na, 2 times 23 plus 2 times 35.5. Forty-six plus 71. Yeah, it will be the same. The total mass of the reactant equals to the mass of the product. So it means we can use the ratio of coefficients, they also known as the mole ratio, to find reactant of the mass of the product. Okay, let's identify reactants, product, and then the states from the chemical reactions. Reactants, yeah, any species to the left of arrow. So it means sodium and chlorine, yeah, is to the left of arrow. It means is it reactant. And how about sodium chloride? Yeah, the species to the right of arrow. This is the product. And how about the state of sodium? Is solid. Solid is gas, and sodium chloride is solid. L is a symbol for liquid. water solutions. When we add water into the solid, the states it will be aqueous with our water solutions. What is a mole ratio? The mole ratio, amount of entities in a chemical reaction. For example, from these reactions, 2H2 gas react with O2 gas equals 2H2O gas. We can see from the coefficient in front of the molecule. In front of hydrogens, we have 2. In front of oxygens, there are no. It's mean 1. And then in front of H2O, 2. It means the mole ratio will be 2, 1, and 2. So for these reactions, the mole ratio will be 2, 1, and 2. We can use the mole ratio to solve a problem. For example, how many mole of ammonia can be produced from 3.12 moles of hydrogens? This is the reactions involving production of ammonia from nitrogen gas and hydrogen gas. The first step, we have to check, these equations balance or unbalanced. We need to know this equation balance. There are 2 nitrogen atoms and also 2 nitrogen atoms, balanced nitrogens. And how about hydrogens? 3 times 2, it will be 6 hydrogen atoms. 2 times 3, it's also 6. It's already balanced. And then, how many moles of ammonia? So the question is about the mole of ammonia. This is ammonia, NH3, the chemical symbol of ammonia. Can be produced from 3.12 moles of hydrogens. So the mole of hydrogen gas is 3.12 mole. This is mole of hydrogen. To find mole of ammonia and NH3, we can use the mole ratio. We put the coefficient of NH3 2 over, and then we compare the mole of NH3 compare with mole of hydrogens. 2 over 3 times mole of hydrogen gas. So it will be equals 2 over 3 times 3.12 moles. Okay, 3.12 divided by 3. What is the answer?
1.04.
1.04. And then we multiply by 2. It will be 2.08 mole. The way to calculate mole, known reactants or the product. And then let's go to the sample questions number 1. Yeah, we can calculate gram if we know the mass from reactant or products, we can also find mass if we know the volume of reactant or the product. The first questions, yeah, we will find mass if we know the mass from reactant or the product. How many grams? Yeah, grams is the unit of mass. So this question asks about the mass of MnCl2. Can be prepared from 52.2 grams. This is also the mass. Mass of MnO2. We have Ar and then the chemical reactions. How to find? We have to remember the simple triangles involving mole, mass, and Mr. Okay, we need to know mass. We have Mr from the Ar, so we need number of mole of MnCl2. So there are 4 steps to solve these problems. Yeah, we need to know the mass of MnCl2, right? The mass, the formula of mass, it will be mass equals mole times Mr. We can calculate Mr from the Ar, but we don't have number of mole. How to know number of mole MnCl2? We can compare with the mole ratio between MnCl2 and MnO2. So we need to know mole of MnCl2. How to know the mole ratio? Yeah, between MnCl2 and MnO2, we need to know mole of MnO2. And how to know mole MnO2? We need to balance these reactions. So we have to check these reactions balanced or unbalanced. The fastest way to check the reaction balance or not by checking the total number of oxygens in reactants or in a product. Let's check total of oxygen. There are 2 oxygens and also there are 2 oxygens. It means this reaction already balanced. We can check, is it correct or not? This is 1 Mn and Mn. And then go next to hydrogens. The next step, hydrogen, 4 hydrogens and also 4 hydrogens. Next, chlorine, 4 chlorine and also 2 plus 2 is 4 chlorine. Balance. So this is the balance chemical reactions. So the next step, find mole of MnO2. How to find mole MnO2? We can use this formula because we have mass. Mass over Mr. Mass over Mr. What is the mass of MnO2? From the questions we know 52.2 grams. We have already calculated the Mr, right? What is the Mr MnO2?
87.
87. Okay, correct. 87. So mole of MnO2 what is the mole of MnO2? What is the result?
0.6.
Yeah, 0.6. It will be 0.6 mole. 6 mole. And then we can determine mole of MnCl2 using the mole ratio. What is the mole ratio in MnO2 and M? Mole MnCl2, it equals, we put the ratio of MnCl2 on the top, so it's mean MnCl2 1, right? 1, and also coefficient MnCl2 1, so it's mean 1 over 1 times NO2, because we already known the mole of MnO2. It means moles MnCl2 is equal with mole MnO2. So the mole MnCl2 same 0.6 mole. And then let's calculate mass. Mass, the formula of mass is moles mR. What is mole of MnCl2? 0.6. Yeah, it's equals 0.6 mole times the mR. What is the mR of MnCl2? mR MnCl2 55
126.
plus 135.5 times 2. It will equals 126.
Yes.
126 grams. Yeah, because this is relative atomic formula mass. It has 126. So what is the mass of MnCl2? The unit of mass is gram.
75.6 gram.
75.6 gram. This is the way to find mass. If we know the mass from, it can be reactants or it can be products. From mass to mass. We use these equations. We use the simple triangles: mole, mass, and mR. Okay, understood? About from mass, from reactant or products.
Yes.
Do you have any questions? Yeah. Can we go to the next slide?
Yes, miss.
Yes. Okay. Go on to the next sample question, the question number 2. What mass of sodium hydrogen carbonate? This is the chemical formula, sodium hydrogen carbonate. What mass? So it means this question has mass. The information not from mass, the information from centimeter cubes. This is the volume. So we have to remember the simple triangles involving mole and volume. Mole, volume, and molar volume. Can we react with excess sulfuric acid? This is sulfuric acid to produce gas. So it means the product that has a volume 700 centimeter cube is a gas. What is it? Gas. Aqueous water solutions is not gas. This is the symbol of G. So actually the gas is carbon dioxide. Water in the state of liquid. So 7,000 centimeter cubes is the volume of CO2. The gas of carbon carbon dioxide. Yeah, we need to know mass. Yeah, what is the formula to find mass? To find mass,
10 times mol.
we can use mass. It will be equals. This is mass, mole, and mr. Mass will be equals mole times mr. We can calculate mr, right? Because we know the AR of Na 23, 1, 12, and 16. So we need to know number of mole. Yeah, how to find number of mole of sodium hydrogen carbonate? Yeah, by the compare of mole ratio between sodium hydrogen carbonate and carbon dioxide. Yeah, because we can find mole from carbon dioxide from the volume using this formula. So that is consists of first step. We need to know the mass of sodium hydrogen carbonate. How to find the mass? Yeah, we need to know mole sodium hydrogen carbonate using the mole ratio. How to know the mole ratio? You need to know the mole of carbon dioxide. To find the mole of carbon dioxide, we need to balance these reactions. Is it balanced or unbalanced? We have checked these reactions. The fastest way by calculating the total number of oxygens in the reactants or the products. 2 times 3, it means 6 oxygens. 4 oxygens. This is 4. 2 oxygens, and also this is 2 oxygens. 10 oxygens in the reactants, and then 8 oxygens. This is unbalanced. How to make it balanced? We need to put the coefficient in front of the molecule. Which molecule it will be?
CO2?
We need to put, CO2. What is the coefficient in front of CO2?
2.
Yeah, 2. We need to put 2 in front of CO2. So it means it will change into 4. 2 times 2 change 4. So it will change to 10. Balance. You can check to sodium to sodium equals. So the balance chemical. So this is the balance chemical reactions. How to find number of mole carbon dioxide? We can use these equations involving volume and molar volume. Mole equals volume over molar volume. What is the volume? 700 centimeter cubes, because the unit of the volume is centimeter cubes, so the molar volume, 24,000 centimeter cubes. What is the number of mole of carbon dioxide? 7 over 24,000.
0.0029.
0.002. The unit of Vm is centimeter cubes over mole. We can cancel centimeter cubes. So mole minus 1 will change into mole. And then find the mole of NaHCO3 using the mole ratio. So mole NaHCO3 equals, what is the coefficient of mole NaHCO3? We have 2, right? The coefficient NaHCO3, we put it on the top. And then the coefficient of CO2, also 2, times mole of CO2. It means equals, right? We can cancel 2 over 2 equals number of mole of carbon dioxide
0.002.
0.02 mole. And then the last way to find mass, yeah, the formula of mass is mole, right? Mole of NaHCO3 times mR. Mole is 0.02. 0.02 mole times mR. Let's we calculate Na 23, H1, C12, and then oxygen 16. 3 times because we have 3 oxygen atoms. 3 times 16. What is the mR?
84.
Yeah, 84. 84 gram over mole. 84 gram over mole. We can cancel mole and mole minus 1, so the unit is gram. What is the answer? 0.02 times 84. What is the mass of carbon dioxide? 168 gram.